So guys, good morning. This is a continuation of our lesson yesterday. Yesterday's lesson was all about summation notation. So we do summation. So we have the limit as n approaching positive infinity. We have the summation of this, meaning we are going to do areas under the curve. We're gonna have to add all areas under the curve, right? So we have from k equals 1 to n, and then pi over n cosine pi over n k. So yesterday's formula for this one was the limit of the function as n approaching infinity. We're gonna have the summation from k equals 1 to n, and we have b minus a over n, right? Get me? N is the number of subintervals, and you have the limits from a to b, so you're gonna subtract the upper limit minus the lower limit, and then times the function itself. We have a, meaning the lower limit, a plus b minus a over n times k. Okay, and then we're gonna have to do this particular given function, that our a must be understood to be this is the imaginary x that we're gonna have. Okay, this is the imaginary x, so I can just put this as this is our imaginary x. Okay, here guys. So can you listen here? No side conversation, please. Okay, so which implies that pi over n, so meaning to say our lower limit is, since there's no a right here, it is understood that a starts at 0. Did you get me?
Yes.
There's no a in here, there's no number in here, that means it is understood to be 0. Yeah, so understood to be 0, but do we necessarily write 0
I don't know.
then plus? No need, right? So the limit would be the integral from 0 to pi. Okay, and this is our imaginary x. Get me, guys? That is our imaginary x. Therefore we say cosine of x dx. That's how we do this one. So it says integral's lower limit is 0, so the lower limit is 0. But this one, this is pi, so this means upper limit, which is pi, minus the lower limit. So pi minus 0 is just pi. You get me? Over n, which is the number of subintervals. It depends. Okay, so let's move on to the second one. It says integral's lower limit is -3. So we now write the lower limit, which is given as -3. So this is the lower limit. You get me, guys? This is the lower limit. So, but look at the numerator right here, 5. Where do you think is 5 came from? It's coming from the lower limit, the upper limit minus the lower limit. This is the x right here, and we need to know what x is that. Now if this is 5, so we normally say can we say 2, positive 2? Upper limit, what is the upper limit? 2 minus the lower limit, so 2 minus -3. What is 2 minus -3? 5 or 5. Okay, so we have 5 over n. Did you get me, guys? Okay, so but it says right here cube root. So this is our imaginary x. This is our imaginary x. Do you get me? Yeah. Okay. So which means the cube root of x dx. Okay. Any question? Next, moving on to this one. So, what you notice, it says the integral's lower limit is 6. So, the lower limit is 6. You get me? And 6 is the a, which is this one. Okay? 6 is the a. So, this is now our imaginary x. But what is that? It's gonna be square. Here, guys. Now, for us to identify the upper limit, we all know that the numerator right here, the b minus a equals 9. You get me? The b minus a is equal to 9. So, we're gonna have to do the upper limit right here. So, what do you think is the upper limit? A number minus 6. What is a number minus 6? Would be equal to 9. Huh? A number minus 6 equals 9. What must be that number?
15.
15. Very good. So, 15. So, 15. Clear now, guys? Okay? Because this is 9. And then, the a right here, the lower limit is 6. So, we're gonna identify, we're gonna find the upper limit. So, by doing a number minus 6 is equal to 9. So that number must be 15. 15 minus 6 is 9. Here, guys. Okay. So, as I said, this is our imaginary x. So therefore, we're going to have 1 over x squared. This is our imaginary x inside right here. And then dx. Okay? dx. Okay. Any question on numbers 1, 2, and 3? Yes.
Write the x in parentheses.
Doesn't matter if you do. Your question is why is it that x is parentheses? I just make sure because I have set this one as imaginary x, right? So you can have 1 over x squared, or you may write it that way also. Doesn't matter. That's a good question. Okay. So can I move this up now? Yeah. So we have to do number 4, 5, and 6. Okay, write the summation. So we do the reverse. Okay, we do the reverse. So we are writing in the form. What is that form? The limit. We have the limits of the function and approaches infinity, right? And then we have, what is that? The summation from k equals 1 to n, and then we have b minus a, meaning the upper limit minus the lower limit over n. Okay, and then times the function itself, the f of x, the function. That is why a while ago I put parentheses. That's the imaginary x, f of x. And what is this? A, meaning the lower limit, plus of course b minus a over n times k. Okay, times k. Okay, so we're gonna have to do it this way. From this one, we do the opposite, the reverse. So how we write now for this particular given the integral from -3 to +3 x squared dx. So we're gonna start writing the limit as n approaching infinity, and then we have the summation from k equals 1 to n And then what we do now, the upper limit. What is the upper limit in here?
3.
3.
Yes.
Okay, we say 3 minus, what is our lower limit? Negative 3. Negative 3 over n,
Over n.
right? Over n. Now, before I continue, is this clear?
Yes.
So we're done with this, right? B
Yeah.
minus a over n. And what's next? Times f of x. Okay? So what is our f of x? Defined as a plus b minus a over n times k. Do you get me?
Plus
Okay. What is a given?
6.
A. A is the lower
Negative 3.
limit. So negative 3. So negative 3 plus, we're gonna have b minus a. So we say 3 minus negative 3 over n times k. Is this clear, guys? Okay? So we're gonna simplify. So the limit as n approaching infinity, the summation of k equals 1 to n. And what is 3 minus negative 3?
6.
It's gonna be 6. So we say now 6 over n. Now is this clear, guys?
No.
Okay, so what's next? We're gonna have negative 3, right? This one. So negative 3 plus 6k. You can multiply k right away over n. So this is now the summation notation of this particular definite integral. Why this is called definite integral? Because this has a limit. Once the integral doesn't have limit, so it is called as indefinite integral. But since it has limits, the lower and the upper limit, so that becomes definite integral. Okay? So, can you copy down? Please feel free to ask questions, guys, because our solution for number 4 overlaps to the space for number 5, right? So I'm gonna erase this so we can start number 5. Guaranteed, guys, one problem will come out in the actual AP. One problem, 1 or 2, at most 2, for this particular topic. You're gonna have to rewrite in summation notation.
Okay.
Okay, are you guys done? Chris, done? Okay, can I move this up? Ladies, done? Okay. So let's do number 5. What is the lower limit? What is the lower limit? Or can we do mental math right away without keeping or without writing the formula? So can we now say the limit n to infinity, and then the summation k equals 1 to n. This is n, okay?
Okay.
And then we say, can we write right away 5 minus 2? Can we write right away 3? Are you guys okay? Comfortable with that one? So the upper limit, which is 5, minus the lower limit, which is 2. So what is 5 minus 2? It's gonna be 3. So 3 over n. Here, guys. Next, what is to be written right here? The first thing that you're gonna write, 2. Why? Because this is a, right? So the formula a, so which is 2 plus what? 3 over n times k, or we can just say 3k over n. Do you guys get it? Okay, so 3k over n. So this is now the answer. But That's not. This is 1 over. I'm sorry. Okay.
1 over.
Okay, because I'm sorry, I forgot that this is 1 over x. So it's gonna be 1 over 2 plus 3k over n. Okay, please include 1 right here, the
Okay.
numerator.
Mr. Roy,
Yes.
for number 4, do you square it since it's x squared?
Yes, it was.
So the final answer, the f function, you have to square that.
Okay, that's a good question, Anthony. So finally, I'm gonna rewrite, okay, to make it clear. So for number 4, we have the limits as n approaching infinity. And you have this k equals 1, and then we have 6 over n, right? Okay. Then this one should be negative 3 plus 6k over n squared. Okay? So moving on to number 7. Numero 7. Now,
Shit.
let's take a look on number 7. What is our lower limit? 0. Do I have to write similar to this one, the 0? No need, right? No need. Okay, so what is now our limit? The limit as n approaching infinity, and you have k equals 1 to n. And what is this? Upper minus lower, so 7 over n, right? So 7 over n. Next, do I have to write 0? Do I have to write 0? No need, right? We don't have to write the 0 anymore because 0 plus the imaginary x. And what is our imaginary x? We're gonna have square root, right?
Square root.
Okay, square root of x times 7k, right? 7k over n. Any question, guys? Okay. So, I'll just do until number 7, and then we're gonna have to do the next topic, which is fundamental theorem of calculus. The topic 6.4. Okay, the FTC fundamental theorem of calculus. So number 7 will be the last discussions, guys. Is our numbers 4, 5, and 6 clear? Can I delete this one? Can I move this up? Yes. Okay. Okay, given what is 1 over n? Isn't it from a while ago? This was similar to b minus a. Okay, b minus a over n. So we have b minus a over n. So the numerator b minus a. But look at the numerator. It's gonna be 1. So 1 is the result of. Now look at this. This is the catch, guys. Look at this. What should be our x? This is our imaginary x. Can I just put a dotted circle for an imaginary x? Why you notice? Is there a lower limit that you can see from the given dotted x? It's gonna be 1. The lower limit is 1. Very good. Okay. So the lower limit is 1, but look at the numerator. It's gonna be 1. a number minus 1 equals 1. What do you think is that number? 2, right? 2 minus 1 is 1. So the upper limit is now 2. Okay? Now, since this is multiple choice, so we can knock out, what letter can we knock out?
A.
So A, we can knock out A. So that's the first thing that you're gonna analyze.
Knock
Okay?
out.
We
Knock
knock out also
Knocked out.
the D.
0.
So these are the possible candidates, right? Possible candidates. Now, as I said, what did I say a while ago? This is the imaginary X. So, can we answer C or B? Which of this?
B.
Huh? It's gonna be a B. Why? Since this is our imaginary X, so this must be our X. Do you get me? So, this is the right answer. So we cannot have this because, or else we have, if you include 1 plus X, remember, our imaginary X would be the sum of the lower limit and the X.
Yeah, at least this one.
But just have this as X. That is why I put dotted circle. Clear, guys? This is not a function. Okay. So,
Bro.
so is topic 6.3 clear, guys?
Yes, sir.
So we now move on to topic 6.4.
Huh?
Oh, turn it off? Oh, never mind. I thought it was like